Hey YouTube, my name is Trent. I am a graduate student at Pittsburgh State University, and I have conducted a project determining if biodiesel reduces exhaust gas emissions versus diesel fuel, and I did this in our automotive lab. I'm in the Department of Automotive Technology, and I am in my 5th year of college, so hoping to graduate soon. Um, the overview of this project is basically to compare B100 to number 2 highway diesel fuel or off-highway diesel. We'll look at hydrocarbons, oxides of nitrogen, carbon monoxide, oxygen, and carbon dioxide. And we'll also use the number 5 cylinder temperature just as a reference when running this engine. So it stayed around 135 degrees for the whole test. So not very warm engine, but we still did the test anyway. And then we'll document some factors that affect performance and engine durability if we see them as well. And so you might be asking, why are we even comparing biodiesel to diesel? Well, there's been claims that biodiesel can reduce carbon dioxide emissions by 15%. And so we're going to test that. There's also been claims that it can reduce um, hydrocarbons as well and particulate matter, reducing smog. So it can be better for the environment, is the claims. Biodiesel is renewable, it is biodegradable, and it can be locally produced in the U.S. There are a fairly large number, about 190 filling stations that have B20 blends. So you might not get B100 blends, but a lot of filling stations do have B20 blends, especially if they're in rural areas. And most manufacturers of diesel trucks and cars will allow you to run B20 in their engines. On top of this, biodiesel is comparable in the price of diesel. For example, $3 a gallon for diesel. The diesel gallon equivalent of biodiesel could be around $2.90 to $2.95 to even $3, close to the diesel price. So it's very similar to the price, and it does provide slightly less range, fuel economy, and slightly less power. However, if you do end up getting a cheaper biodiesel price, then it might be worth it for you. And we'll look at that in this test. The research question is, does running biodiesel reduce exhaust gas emissions? So we'll see that. So step one in this project is to understand the difference between diesel and biodiesel. This is a typical diesel molecule with 14 carbons and 30 hydrogens. Biodiesel is very similar with 17 carbons, 34 hydrogens, and biodiesel does contain, this is important to know, 11 to 12% more oxygen than diesel. So also a big difference between diesel and biodiesel is that biodiesel is composed of organic fatty acids derived from animal fat and vegetable oils. So that does play into a factor on how it will burn. It is a bigger molecule slightly than diesel, and it is known to gel up quicker as the cloud point and flash point and the pour point are higher than diesel. So it does get thicker at a higher temperature compared to diesel, which can affect engines, and it should only be ran in mechanical fuel injected engines if you're using a high amount. Now, like we just said, most manufacturers will let you run up to B20 in common rail fuel injected engines. Older engines that were mechanical could run pretty much any blend of engines. Is what we're using in the test is a mechanically fuel injected engine. So, and just keep this in mind: the higher oxygen content in biodiesel could show leaner readings with an exhaust gas analyzer, and it could burn a little bit differently than diesel. So we'll see that in our readings. Seeing if I left anything out. Okay. So step two is pretty much to obtain the diesel fuel and the biodiesel. So the biodiesel was made by Pitt State several years ago. So note that too, that the biodiesel is old. It's probably about 5 years old. It was made quite a while ago. And the diesel fuel It is number 2 off-highway diesel fuel, also known as red diesel, and we use that from the diesel lab. So we compared a Cummins B5.9 engine, which is mechanically has a mechanical fuel injection system on it. We ran the number 2 diesel and the biodiesel right after the other to see the results. Step 3. So preparing the Cummins engine to run, basically we connected the battery, checked the oil and the coolant to make sure it could be run, and it did start right up on both fuels. Initially the B100, it did run a little bit rough, but then it smoothed out. And we did let the engine warm up so that we could get as accurate of readings as we could get. And don't forget that I mentioned this engine, which we'll show later, only at least the exhaust gas, the exhaust manifold only got to about 135 degrees Fahrenheit. So that can show a little bit different readings. And then there's our exhaust gas analyzer. And this is the engine. Notice that there's no load or anything tied to the end, so that also is a factor. We did connect the exhaust gas analyzer once it was warmed up, which is a snap-on model. I don't specifically know what year this is. However, it can read a lot of petroleum fuels such as gasoline and diesel, and it can read methanol and ethanol too. So it was an accurate tool to use, especially when we compared it to other studies that have done the same thing. So step 5, we obtained readings from diesel fuel, and here are our readings. Quick to notice that the oxygen content was high, and that is because the probe at the end of the exhaust was diluted with outside air. You know, the probe is exposed to the atmosphere, to the oxygen in the automotive lab, so that can make that look high. And then it can also cause the carbon monoxide reading to go down as well, or even not read at all. In this case, it was just very small. The carbon dioxide reading was pretty low, and that's pretty much indicated by inefficient combustion. So if the engine was indeed running lean, or if it wasn't hot enough, there could be pretty inefficient burning in that engine. So for example, the flash point of diesel is around 55 degrees Celsius, and the flash point of biodiesel is around 130 degrees Celsius. So, like we said, the exhaust gas temperature being 135 degrees, that fuel might not be burning completely or very efficiently at all. So we'll watch this video just to see a short test. And like you saw here, the temperature wasn't very accurate with the probe, so we used an infrared temp gun to take a reading of the exhaust manifold at number 5 cylinder, just as a baseline. We did the exact same test. Sorry about that. We did the exact same test on biodiesel. So once again, you did see a high oxygen content, which made the carbon monoxide reading go down because you're getting an artificially lean condition, which is what the exhaust gas analyzer is reading. And it could be that the engine is actually running lean because it is not a modern computer-controlled fuel injection system. It is mechanically fuel injection, and there's just so much air around this exhaust pipe right here that the probe is picking that up as well, all the oxygen out here. So keep that in mind as well. And so yeah, and this was indicated once again incomplete combustion because of a low temperature. So I did attempt to increase the engine tip by covering the radiator, but it wouldn't go above 135 once again. And I also raised the engine temperature. However, there were minimal changes in that as Verifying that the gas analyzer readings were correct, I used a Nissan Titan. I warmed that up, drove it, got it up to operating temperature. It also uses a Cummins diesel engine. For example, the carbon dioxide output on that engine was about 3%, which is very comparable to our test. So we know that the readings we were getting were similar to a running modern day engine. So that shows us that my test is pretty accurate. On top of that, I found about 5 additional studies with similar results, but here's 3 of them. So in this study, um, at 5% load, their hydrocarbon emissions output was about 12%. In my test with the biodiesel right here, it was about 9%. So I'm happy with that. That's pretty close. Remember, we were at 0 load, and they were at 5 right here. Carbon dioxide output from our biodiesel, 0% load, we had a 1.35% emission reading. On this test, this other study, a separate study, their CO2 emission reading was about 3% with B80, 80% biodiesel, which is very close. This was at a 25% load, so most likely that's going to go down if they reduce the load. So I'm also happy with that. It's pretty close. And then excess oxygen on the biodiesel test with my test in the lab, we had 18.75% oxygen, and this test also had, well, this had about 17.5% with biodiesel. They didn't tell us to blend, but I'm happy with that too because it's close, indicating that we're going to see same results when we had a similar situation happening. Here's some additional findings. So they basically indicate that my test is replicable and has pretty consistent results with these other 3 tests because there's more out there. There's at least 5 that I looked at that had similar results. So our research question overall was, did running biodiesel in an engine reduce exhaust gas emissions? And as it's kind of hard to tell from our test, in the lab, it did. So especially hydrocarbons were reduced from 11 to 9 with the B100 blend. Carbon dioxide output was reduced to 1.35%, and carbon monoxide was reduced, and so was oxides of nitrogen, parts per million. And interestingly enough, biodiesel is not claimed to reduce oxides of nitrogen. However, these engines weren't getting very hot, so this reading might be a little off. And also remember, when engines do get really hot, combustion temperatures, that will increase the oxides of nitrogen. So if we were driving this on a normal vehicle, we might see that this isn't the case. But we do use EGR in most modern day engines, on typically all modern day diesel engines, to reduce oxides of nitrogen. So yes, the exhaust gas emissions were reduced when using biodiesel in the lab setting. We can't really claim this for all vehicles from this test. However, keep in mind that all of these small reductions of exhaust gas emissions will play a bigger part in actual running vehicles. And also keep in mind that there's about 12 million diesel vehicles that are licensed in the world. So probably less than half of those are driving. However, if you take that into consideration, there could be a pretty big environmental impact when you reduce those emissions. So it could be pretty good for the environment. Test variables, remember, we weren't driving it, there wasn't a load. The temperature wouldn't climb that much, and we're not really simulating a driving condition, so some of these readings were a little bit different. However, since these readings in a lab environment basically were replicated with other studies and we found the same thing, we can ensure that these readings are correct for this environment. So we can trust them pretty much. Conclusion, they did conclude that all of these emissions were slightly reduced by using biodiesel, but honestly the test is a little bit inconclusive because further testing would be needed to really claim that biodiesel for sure reduces exhaust gas emissions and greenhouse gases with this test. There have been other tests that have claimed that they do reduce emissions. However, this test did not specifically claim that. To wrap this up, these are the references, about 10 of them, that I looked at and used information from. So thank you very much.